Factor out my GCF, we get 3x, we get x squared minus 4x plus 1. Okay.
Yeah.
Now I have what times what is 1, you add together to get negative 4. So I know for certain,
You have to do like quadratic.
you can use some quadratic formula. That's one way you can go through this one. If I use the quadratic formula, you remember that? The opposite of b minus square root b squared minus 4ac all over 2n. Or we can play your video, which is awful.
It was not. It was
Eventually.
Hollow
Mine
Mackerel,
was the
so
best
it
one.
has
Yours
to
is
be
just
good.
scary.
It sounds awful.
Everyone would love to see it. I was dancing with the dog at one point.
This is Caleb with the dog.
I was just blowing in the air.
Anyway, so you get 4 plus or minus the square root. 4, so 16 minus 4 times 1 all over 2. So in this case, you get 4 plus or minus the square root of 12 all over 2. We okay with that? Remember how to simplify the square root of 12?
2 root 3.
2 root 3. So you have 4 plus or minus 2 root 3 all over 2. So your zeros would be at 2 plus or minus root 3. And then this 0, what do you do with that to find it? 0.
Set equal to 0.
So what's x then?
0.
0. So in this case here you have 3 zeros because it's a third degree polynomials. Remember the rules where you can have up to that many zeros. So it's going to cross the x-axis at 0, 2 plus root 3, and 2 minus root 3. Eventually, as we start to graph these, by it being a third degree polynomial, how many changes of direction can it have up to? 2 of them. So that first term, leading term was positive, so start thinking about the dance moves. Which way are the tails going? It's not. So we know that the tails will be going from here to here. Along the way, it's going to cross 0. 2 minus the square root of 3, we'll call it here, and 2 plus, we'll call it here. It's going to go whee. We'll do that. We'll figure out those relative maximums, relative minimums later on today. Very, very easy to do so. No, but I'm just doing a little bit more of it today so that way you start to see it more because we're eventually going to be doing a lot of it. Just test.
For like 37 to like 37, they were like, so 37 is t to the 5th power
Yep.
minus 6 t to the 3rd plus 9t. I don't remember how to factor it.
Okay. We didn't do one of those in class, did we?
No.
Okay, that's probably why then. That's just not working. Pretty sure once you see it, you'll be like, oh, I remember.
Yeah, I just didn't remember.
First rule of factoring is to do what?
Jesus.
What's the GCF? Do you guys mind if I write it as x?
Yeah.
Oh,
No, I was like, yeah.
We okay with that? Now, what I want you guys to remember, when you are in descending order, if the highest degree and then the next degree is half that and they're all even, treat it like you would x squared, x, and 0. So what times what is 9 you add together to get negative 6?
Wait, can you say that again?
If these two degrees are even and they're one of them's half of the other, you can do this next trick because of the powers and the rules of exponents. We have this x is still here. I can do x squared minus 3, x squared minus 3. If I FOILed that out, what's x squared times x squared? X to the 4th. Then I get minus 3x squared plus 9. So this is actually giving me zeros at 0, plus or minus root 3, and plus or minus root 3. Do you guys remember that those are called repeated zeros? I think the book called them, what do they call them? Multiplicity. Means there's multiple zeros. So there is a multiplicity of 0 at plus root 3 and negative root 3. That means it's touching it there. It's kind of like the idea where your graph is if it was x minus 2, your graph would be lying on positive 2. Those are just lying on plus or minus root 3s. That's what that means. Okay. So we have a fifth degree polynomial. Leading term is positive. What are the tails doing? Which way? If you're looking at it, which are the tails going?
Yeah.
Yes.
It's just fun. We know that the tails will be going. What I do?
And then it's like right when
So we'll call this, if we call this negative root 3 and this one positive root 3, it probably looks like this.
Yeah.
I think it looks like that if you graph it, somewhere like that. Because you have that multiplicity means it's touching it, it's not crossing through, it just touches at that balance, at that spot. So it should look something like that. Tessa, what was the other one then? Like 30?
I don't know, if, just do like 40. I don't know, just like.
Oh, 40? Yeah, 40. 40 is very similar, but what are you going to do first on 40?
What if it's like, it's not like to the fourth and to the second?
Oh, like 41 and 42?
Yeah.
Well, when you look at ones like 41 and 42, it's grouping. Very good. See how there's 4 terms?
Oh,
When
yeah,
you see
okay.
4 terms and it's in a descending order like that,
Okay.
9.5 times out of 10 it's 14 in group.
Okay.
Okay? So if you go to group this one, you just group them how they're sitting. And then you're going to take the GCFs out twice. So you have an x squared, you got an x plus 3, negative 4, this is plus 3. So you have an x plus 3, an x squared minus 4, which is x minus 2, x plus 2. 0 is at negative 3, 2, negative 2. It's positive, odd value, tails are going up. So we got to be going increase, decrease, increase, and go. It should look like that. Not bad? I didn't think this would be that bad. Cool. Make sure your names are on those two and send that up, and we'll talk a little bit about the leftover stuff. Oh, that's fine. I wasn't here yesterday. Oh, wait. But I didn't. Oh, yeah, that's fine. Yeah, that's fine. I'll put that one second.
Were you wearing a club shirt yesterday?
I was.
Saw you open.
Yeah, I did some crazy stuff for extending through. The last bit of this section, let's see if I have it set up here, is we've dealt with the zeros so far. Don't write this stuff out. Remember, the zeros of a polynomial is where it's crossing the x-axis. And you did a ton of that when you factor and you set it equal to 0. What I want to do today is work backwards. I want to work backwards from the 0 to build the polynomial. I know that you guys did this last year, so it shouldn't take very long to go over. For example, knowing that if you have this, if you have terms of x minus 5, x plus 7, if those are your terms, what are your zeros?
5 and negative 7.
5 and negative 7 would be your zeros. So when I say your 0 is 5, you know your term is x minus 5. If your 0 is negative 7, your term is x plus 7. It's going to be the opposite. What if your 0 is 0? What's your term? X. Very good. Your 0 would be x. Again, if your 0 is 0, your term is x. Because think about what that means. When you set x equal to 0, you get 0. That's how that works. Okay. Also, you could do stuff with fractions. If your 0 was, I don't want to do 1/2. Let's see. Let's try 3/4. If your 0 was 3/4, there's a couple of ways you can. Oh no, this is. I'm thinking of a different style. You guys won't see that. Never mind. You won't see that. I'm thinking of conjugates with the roots. We don't do that until we worry about complex numbers. I'm like 2 days ahead of myself. Don't worry about that.
Numbers are like that.
Yeah, we're gonna do complex numbers after, what is it? Synthetic division. Excuse me. So basically what I'm looking at here is if you have zeros that are more than 2 degrees, so if you have 3, 4, and -2, what becomes your polynomial? What would you do?
Oh,
Your polynomial, as you start to build your polynomial, is going to be x minus 3, x minus 4, and x plus 2. How do you write that out then?
X,
Right. You'd have to FOIL it out a couple of times and combine all your like terms. Now, is there any rhyme or reason as to which ones you would multiply together first? No, it doesn't matter at all. I usually just pick the first two and go. You get x squared minus 7x plus 12. And then you have to still FOIL out another, or distribute out an x plus 2. Put everything in a descending order. Oops. And I know you guys have all done this in the past. And this combine your like terms. X cubed, we have negative 7x squared, positive 2x squared. So I get negative 5x squared. 12x minus 14x would be negative 2x plus 24. Okay. And that would be your function. Like I said, shouldn't be so bad because I'm pretty sure all of you guys have done that. I know that we did this before also with the imaginaries, but we'll worry about that later. Those. That's kind of really all I had.
all right, sweet.
Yay.
We probably could do the rest of it. Nice.
Sweet.
One thing I do want to show you guys is they are going to ask you about solution points. And I want to look at number, let's see, what do we have here? I want to look at number 73 together and walk you through how you would set up and find all the values that they're asking for as far as the instructions are concerned. So take a look at the instructions for number 73.
What numbers are they?
That's the day 3 stuff. But I'm going to show you what they're talking about. Find the zeros, graphing, and then how do you find the actual points of intersection or points of change, the relative maximum mins. How are we going to justify what those actual ordered pairs are? So in number 73, the function is 3x cubed minus 15x squared plus 18x, I believe. And it asks you to sketch the graph by using that leading term coefficient test. What that means is, what are the tails doing? Okay, what are the tails doing? Where is it going through the zeros when you factor it out? But what we're going to do is find the actual peaks and valleys between those points where it's changing direction. And it's pretty easy to do. Excuse me. So if my function is f of x is 3x cubed minus 15x squared plus 18x.
Wait, you're doing that?
Yeah.
Wait, then I-
What's the first rule of factoring? What is it? 3x. So my GCF is going to be 3x, and I'm left with x squared minus 5x plus 6. So when I factor that the rest of the way, I'm going to get what?
3x minus.
Very good. So we have 3x, x minus 3, x minus 2. Does it matter which one goes first?
Nope.
Nope. Not one bit. Not one bit at all. Now this is going to give me zeros. Where are my 3 zeros for this function?
0.
We have 0, 3, 2. We know the tails test tells us it's going to go like this. So now what we're going to do is draw an actual continuous curve that makes the most sense. And here's how we do that. First thing I would do is plot my zeros. Okay. 0, 2, 3. I know that it's got to be increasing to 0. And then it's going to decrease to somewhere in here. It's going to change back to an increase. And then somewhere in here, it's going to change back.
What? No.
It's going to come up.
Down.
It's going to do this.
Yeah.
And then it's going to do this. What we need to do is figure out the values that it changes. Okay? Does that make sense? Yeah. Okay. Now, it doesn't always change exactly halfway between the two. But what's nice is that we can find these values called relative maximums and relative minimums. You ever heard of that? Remember that from last year? Okay. Yeah, we call it not. It's not just an actual maximum or a minimum, because in this function itself, since it's continuous to both infinity, because there's no maximum, there's no minimum. We call this a relative max or a relative minimum, or a localized max or a localized minimum, because we're looking at a specific boundary where this maximum is going to occur. Same thing, this boundary where a minimum is going to occur. We're just looking at within some local, that's why they call it local. You're looking within a localized region. And yeah, we're going to use our calculator. So what I want to do,
The picture so
thank you.
but I still
Oh, wrong one. Sorry, I picked the wrong calculator. Where's it? What were you going to say?
because you're recording. I always forget.
Is your wife on?
Yeah.
Like, what happens if your wife watches? And then I'm like, you like one kid more than the other. Like,
I don't like one kid more than the other.
They have
Why would his
every
wife
night they
listen
review
to
his
it?
lessons.
Yes.
I don't watch TV. That's their
Let's see what Daddy did at school. No. It's Curious George or Wildcraft.
Curious George.
Okay.
Moose, how about you?
Moose. Because Yeah. Anyway, that's Moose. All right. So we have x cubed. Oh, sorry. 3x cubed
Theory, we've gone over this like a million times.
minus 15x squared plus 18x. Okay. And we go. Now, when we're looking at this then, obviously you can sit there and look, and you notice that you have a somewhere between 0 and 2, we get that localized maximum to occur. Well, if you look at your table, let's see here, menu 7, and then enter.
Menu 6.
My points here are, they're too far, they're going up by ones and stuff. So you'd have to change your table setting. Remember in the old one, you can change your table setting?
Yeah.
You can do that, you can do a little bit more difficult here. I just looked at that table. I think the option should be like specifically comes out like that. So let's not worry about the table. So with any luck, we can tab up, I believe.
Mr. Murphy, I got lost because menu 7 is heads.
Oh, it's different for you guys. Okay, here, let me start over. Okay, then go back to the graph. Go back and redo that. I totally forgot that I have the different, my software is different on this one. I'm sorry. I completely forgot that you guys have the little bit the older software.
No, mine's menu 7 is table.
Yours 7 isn't table?
Mine's 7.
No, mine's
Table.
heads.
Huh. I didn't know that. We might have to, I'll have to update your software then. No big deal. So we have 3x cubed minus 15x squared, and then it was plus 18x to be done with it. So we go back and just look at our graph.
Can you change the zoom standard to maybe what you want it to be?
I believe so. I never really messed around. I haven't really messed around with the zoom because the only thing I've done with that is just kind of zoom in and out off over a specific value. I haven't really had to do anything else with it yet, but I'm pretty sure you can do that. So let's do this. We can do. Remember how last year we had the button that said calculate? This year we use the one that says analyze. Okay. So we hit menu, analyze, and we're going to look for a maximum. And we're going to do that whole boundary thing. We're going to change the boundary, the left hand, the right hand, like the upper and lower. I think this one calls it the upper and lower bound. So we're going to move our, you can move it to wherever, really anywhere you want. You want to make sure that your lower boundary is to the left of what you're looking for, and then your upper boundary is to the right of what you're looking for. Very similar to what you guys did last year with your left hand, right hand, all that kind of stuff. So we just hit enter, and then it automatically goes for the upper bound. Oh, did I hit minimum? Yeah, I apologize. I hit the wrong value on that one. So let me go back to my menu and hit analyze again.
Do we either do this twice to find both of them?
Yeah, you'll find the minimum, you find the maximum.
No. I mean, like, you find both maximum, do we do it twice?
Well, one of them is a maximum, the other one is a minimum. I just, when I looked through my stuff here, kind of wouldn't it have made sense to put maximum in front of minimum because it's alphabetical? Whatever. So anyway, I'm going to go back and do my lower bound.
What? Mine uses 7.
That's 75.
No.
And it's going to give you some value, I believe. All right, so there's my lower. There's my upper. I'm getting a maximum of 0.75 or 785.
Yeah.
So let's do. Is that what you're getting?
785, 6.34.
Okay, it really depends on the round and where it rounded through it, or how close you are. It could be. What happens if you don't have the zoom, like as clean as you really can? Oops. Grab this one. If you don't have the zoom out a little bit, you might not know exactly where you are when you're crossing. So sometimes you're going to have to mess with it a little bit. Just see how close you are. But it's basically the exact same thing as what you did when you found your maximums and minimums with parabolas. Just have to remember that you're looking for a maximum at this point and a minimum at that point. Bless you. You might have, if it's like a 4th or a 5th degree polynomial, you might have numerous ones to look for to get those, what are called points of inflection. Yeah. Changes of directions, where it's changing direction. And that's what you're looking at. Those will be your hard points, and that way you can just label that point of where it's changing and just draw through it. Does that make sense? I don't think it was going to be really that bad. The main part here is the idea of what we've been working on is, can you identify your zeros? Do you know what your tails are doing with the dance? And then go from there. The relative max, or localized max, the localized minimum, that's really when it's a being calculator. Because if we start doing it via the table, you'll be sitting there all day. Just kind of silly. So, yeah, we should be okay then. We'll do synthetic division and long division tomorrow. Maybe it might take Friday to do some of that long division stuff because I know how much you guys remember how to divide. Yes.
I'm still confused by the thing you showed earlier, like I just wanted to see.
Which one? With the higher degree?
Yeah.
Okay. When you have the higher degree ones with when you had like a 4th squared and the other, is that what you're talking about?
Yeah.
Okay. If you look at one like that, let's look at number 39. If I have to factor number 39, yeah, if you guys want, then just do the day 3 stuff. It probably won't take you 15 minutes. I don't think. If you want to start with one like 39, you still go through your factoring like you would normally. You start with GCF. Do you have GCF? What is it? 5. So you take out a 5, and you're left with x to the 4th plus 3x squared plus 2. Whenever your degrees are going in a descending order with even powers,
Okay, so it could be like, oh, when there has to
Nine,
Eight.
eight, two.
yeah, because you go 8, 4, then 9.
be. Okay.
See what I'm saying? 8 works like that way. Because what you wind up being able to do here is, well, what times what's 2 you had to get 3? It's still x plus 2, x plus 1. But if you square that, like that,
Oh,
you get
okay.
x to the 4th,
Yeah, that makes
and then you get the other. And it would still, even still, if this was like a 6 and a 3, wouldn't this be 3 when you multiply them together? Once you add your exponents, it still works.
Okay.
So as long as you're getting cut in half, it works. And you treat it the exact same way. A lot of times with those, you wind up with when it was the 4 and 2. Here you can't square them, or you can't root them any further because you get imaginary roots.
Yeah.
But a lot of times, this stuff will hide difference in squares.
Okay.
That's the trick that you see. Does that make more sense?
Yes, thank you.
Coolio. Remember that guy?
Yeah, he was weird.
Fantastic.
So let's watch some Project
5 rides to decide where's my 65. It was awful. I mean, it was awfully awesome.